So welcome to our second session. So the focus of this session, chapters 2 and 3. So these are chapters that you actually, I think, did cover in some way, shape, or fashion last fall. So this literally should be review. So that's a good way. It's a good segue into what we're doing. Just to look ahead, so I think maybe the last chapter that you sort of went off from is chapter 4. Did you do chapter 4? Savings, it's the goods market. That's probably about where things started to break down, I think, but yeah. So, okay. So today should be a review. And that's good because we want to sort of jump into this and be able to, kind of orient ourselves and not have everything be new right away. And then next week will be chapters 4 and 5 are connected. So chapter 4, there's stuff going on, but I want to make sure the level at which you covered the things in particular in chapter 4. To make sure that you understand the nuances, and maybe you do, and maybe you don't. That's what I want to kind of figure out today. So my plan, and we can be flexible about this. I can do it differently. So I need to hear. I need to hear from you, and I need to hear from you just with something verbal or in the chat when I'm done talking here in a second. That I will go through some main points in a chapter 2, in this case, first of all, for a bit. And then say, okay, what questions do you have about this? And the hope was that you would have some questions that you might be bringing forward to the session, before this. Another way that we can do it, which is the opposite of that, is to say, we start with your questions so that we're focusing on the things that are of most interest to you. And then I can end up covering all the stuff in that chapter in that kind of way, in a more organic kind of way. And I'm okay with that too. I can do that too. So, but my thought was it would be a little, I'll just say a lecture, right? But and then hopefully that generates some questions versus questions generate the discussion. What's your preference? So I need you to unmute. I need you to.
I would actually prefer the second, but I would be happy with either.
I agree. I prefer the second.
Okay.
The second is fine.
All right. I prefer that too, actually. But so what that means for now, and what that means going forward in our sessions, is that you, just to be clear about that, you need to bring some questions to start the process off, right? For these sessions, for our sessions here, as a launching pad for the discussion. Okay. So go ahead. So let's start. And ultimately, I'm gonna bring up the document camera. That's gonna be probably our not necessarily, it could be things in the book as well, but in fact, I just X'd out, so I should leave my browser open because maybe I should have left that. Hold on just a second. So let me just kind of cue that up as well in case we need to go into the book for anything that might be useful. You see me looking over to the side. I have another monitor over here. That's why. So let me bring up the textbook just so I have that ready to go in case we want to go to that in the future. I'll just have that ready up and ready to go. any questions in general that you want to, before we sort of launch into stuff, econ stuff? All right. Anything, any questions that you have that before we start that? Well, everybody's doing okay? All right. So chapter 2. What's the main idea? What are the, I'll just say the main idea. Yeah, what's the main idea in chapter 2?
It went over how the economy is measured.
All right. So why do we care about that? So I would argue chapter 2 is a foundation chapter. It's building foundation. Yeah. So why do we care about that?
We need some basis of measurements in order to study progress within the economy, either negative or positive. And
okay. So so I am gonna switch over to, whoops, that's not what I wanted to do. Sorry, I am going to share screen. So if I'm thinking about, so what are the variables that we care about and that are discussed in chapter 2?
Gross domestic product.
Okay, so GDP. All right, so GDP, and then we have nominal and real. All right, we'll come back to that. So GDP is one. What else?
The price level.
Okay, the price level. So the price, the overall price level in the economy. We could use the consumer price index. We could use the personal consumption expenditure price index. That's what the Federal Reserve uses when it's looking. The one that's usually in the news is the CPI. And what goes along with the price level? What's the other variable that we end up that's derived from that?
Inflation.
All right, so the inflation rate. All right, so the inflation rate. Inflation rate is simply the percent change, right? That triangle means change, Greek delta, right? Percent change in the NP, or percent change in the CPI, for example, right? From year to year, month to month. Price level is measured monthly. Real GDP is measured quarterly, although adjustments get made each month. So, so if you were in my class right now, or any semester for that matter, you would have a subscription to the Wall Street Journal, and we would be weekly. You'd be doing something with that, and then ultimately the idea being that we need to see what's actually going on with these things in the economy as they get reported, because when they come out as reports each month from the Bureau of Economic Analysis, from the Bureau of Labor Statistics, that becomes a Wall Street Journal or New York Times article, right? That's news. That becomes news. So when those reports come out every month, and so there's actually a calendar of economic indicators, right? These are all economic indicators. So this is about measuring the economy, measuring economic activity. And because they are economic indicators, right? They indicate what? The health of the economy. How are we doing, right? That's the question. How are we doing? Okay. So we need to know what they measure and why we care about these particular economic indicators, because like there are an unlimited number of variables, things that we measure in the world, in the economy. Why these, right? So one answer to that is because in the one that's most pragmatic for us is that these are variables that are going to appear in our model, all right, in our analytical model. In chapter 3, we're going to add the real wage, employment, and real GDP is in there as well. In other chapters, chapter 4, we're going to talk about the real interest rate. We'll talk about investment and saving. We won't talk about inflation actually until we get to the very end, and we talk about chapter 9, chapter 8 and 9. And we talk about business cycles. So we want to think of these are all things. So there's one other one that's primarily that's discussed in this chapter. What's the other one?
Is it interest rates or savings and wealth?
Yeah, good point. Thank you. Sorry, interest rates is the one I had in mind, but yes, then we have wealth as well, wealth and savings. I'll come back to that one. So the interest rate. There are multiple interest rates in the economy, right? There's an interest rate you get on money you put in the bank, interest rates you pay on a loan for a house, interest rates you have to pay for a car loan, interest rates that the government has to pay on treasury bonds when it sells treasury bonds because of a budget deficit. So there are many, but we just assume we just make that simple, and we just talk about the interest rate in the overall economy, right? Because our goal, the reason that this is just this is a foundation chapter, in the same way that chapter 1's a foundation chapter, it's kind of setting the stage, right, for what we're really after in this course. And the chapters that we're going to focus on, it's how do we model, how do we explain, how do we analyze what's going on in the economy. But we need to know what we're talking about in order to make sense of all that. And this is the part of that first part of that. Like, what are we talking about? What do we care about? So interest rates, we have nominal interest rates and we have real interest rates. So what you see from the get-go, right, are this difference between nominal and real. And what we care about, so nominal interest rates, those are the interest rates that you actually pay, right? And just sort of in the real world, that's what you pay. So we use I for that, the nominal interest rate. And what's the real interest rate? We use R for that. That is the nominal interest rate, what, minus the expected inflation rate. Yeah, inflation rate. So if we say, well, the interest rate I have to pay for a car loan is 4% and inflation is 1%, then the real interest rate is 3%. Okay. Let me go back up to the price level, because actually they don't really talk so much about CPI and these other price indexes. Talk about the GDP. Another way we can measure the price level is the GDP deflator. All right. And that's simply nominal GDP divided by real GDP. And this whole thing times 100, but yeah. All right. So this is another measure of the overall price level in the economy. So we can look at the GDP deflator year by year and get a notion of inflation. What's the difference between these different ways of measuring the price level in the economy? It's what's included in the measurement, right? So the consumer price index measures how much it costs for a market basket of goods and services that a typical urban wage earner would purchase in a month. Literally, it's like having a shopping list of stuff, goods and services, and they measure how much it costs for that shopping list every month. They actually do it all over. The people that do this all over the country, in Boston, in New York, in Kansas City, in Minneapolis, in Dallas, in San Francisco, in Denver, right? And then the overall CPI is can be an average of all of those, right? So the cost of living, right? The cost of buying that market basket of goods and services is going to be different in different places in the country, and how it changes from month to month. Probably less different, but it's the changes month to month that matter for measuring the inflation, right? But it's a fixed market basket of goods and services. the personal consumption expenditure price indexes allows that market basket of goods and services to change over time. There are technical ways that they can do that to take that into account. So it's perhaps one of the problems with the consumer price index is that you have a fixed market basket of goods and services, and you have the prices of some things going up. Well, what do we do as consumers? We substitute something else. So the impact of the price change isn't as much as the CPI would suggest, because we substitute to other things that some at the margin substitute to things that haven't gone up in price as much. That's what the PCE tries to get at more. The CPI is used to index a number of things. Social Security payments, for example, each year go up by the rate of change of the consumer price index. Tax, the levels of income where different tax rates kick in are indexed to inflation, and they use the consumer price index. Some people have, there's been legislation to say we should use a different price index because that tends to overstate the level of inflation because of this fixed market basket. There is a bias upward in that sense. So politically, it's been an issue as well. So some, I'm trying to think which may have been in the stimulus bill early on, not COVID related, but the early stimulus bill in the Trump administration, where the legislation actually changed that price index for the tax brackets, because so it's an interesting point. The tax level where tax rates change goes up by the level of the consumer price index, but if that overstates things, then if you use a different price index that doesn't do that, then those tax bracket income levels don't go up as much each year. So therefore, if your income goes up, you're more likely to be in a higher income tax level. So it's interesting. So there's some minutia around that, but what we're interested in is inflation rate. We're not going to really come back to that until chapters 8 and 9, though, right? So we are going to focus on is GDP. So let me come back to that. So there's 3 different ways we can think about measuring economic activity in terms of GDP. So what are they?
The income approach, the expenditure approach, and was it production?
That's correct. Income, expenditure, and production. So we can literally measure. So the production is kind of the way we think about just the definition of GDP, right? It's the so nominal GDP, the dollar value of all final goods and services produced in the economy in a year. Like all parts of that statement are important. So it's measured in current dollars, or in the United States. Other countries, it would be whatever the currency is, right? Current value of all final goods and services. So it's just stuff that's produced for their final use, not as inputs into some another product, but final goods and services, right, in their final use. So for example, we would include in GDP the production of automobiles, but we would not include the production of radiators that go into the car, right? Separately. That would not. Why not? Why don't we do that?
We would double count considerably.
Right, we double count because the value of those radiators is already included in the price of the car, right? So it's final goods and services that matter. It's newly produced final goods and services. So for example, in the case of houses, right? It's not, we don't add up all housing sales of houses, only sales of houses of newly produced houses that year, right? Existing houses aren't, that buying and selling already existing homes do not contribute to GDP because they contributed, again, double counting issue, they contributed to GDP in the year that they were built and sold originally. It also includes just market-based things. It doesn't include the value of, say, babysitting that a mother-in-law does for somebody, for their son and daughter-in-law, their grandchild, right? It doesn't include that. It's unless they're getting paid. So it's the value of all final goods and services, newly produced final goods and services produced in the economy in a year. So expenditure. So here's a useful thing that will serve us well over the next 5 weeks, including today. You can think about what we're doing in this course, and think about the macroeconomy and trying to understand it and model it as a play, right? The stage is our economy, right? And the scenes that play out on the stage, right, have to do with the interaction of the different actors on that stage. So who are the actors in our model? Who are the actors in our economy? Well, the actors are households, consumers, right? Us, individuals, right? Households or individuals, consumers, right? And so we call this expenditures by households and individuals consumption, right? That's C. Then we have firms, another set of actors in our play, right? Our play called the macroeconomy. They buy and sell goods. What they do is they buy goods and services, right? In terms of GDP, newly produced final goods and services, they buy things like machines, put up new buildings, new warehouses, new production facilities. They buy software, which is also part of investment. And so, sorry, I just said it. So that's what we call investment, right? By firms. Spending by the government on newly produced final goods and services, right? G. And we have net exports, exports minus imports, other countries. So the actors are households, firms, the government, and other countries. We'll bring in the Federal Reserve later as well as kind of another actor, another guest, a guest appearance in our play. And so we can measure the spending by each one of these actors. And if we tally that all up, it has to be the case, just from a GDP accounting identity standpoint, that everything that's produced has to be accounted for in terms of expenditure. But you could ask, well, yeah, but what happens to the stuff that gets produced but isn't bought? Well, that's called addition to inventories, and changes in inventories are part of investment. That's the way we make sure that from an accounting standpoint, GDP accounting standpoint, that everything matches up. All right. So changes in inventories are part of I. So are new houses. So are new sales of new houses, even though that's done by consumers, households, but it's more like buying machines. So it's included as part of investment. It's just a quirk of the GDP accounting. Why do we have net exports on here? That's exports minus imports. So why do we have to, so to get a measure of the value of all goods and services produced in the economy in a year, why do we need to subtract off imports? Why is it net exports? Why don't we add imports? Why do we have to subtract them off? Welcome. It's glad to see your, happy to see your face. So why do we have to subtract off imports?
I'm assuming because it wasn't made in the country.
Yeah, that's half of it. So that's half of it. Why don't we could just ignore them. All right. We could just ignore them then, like not even deal with them. But we have them in there with a minus sign, actually. So that's half, yeah, that's half right. That's correct. What your statement is correct, right? But it's only half the story. And the reason is because part of what we spend money on as consumers, like you buy an iPhone, for example, right? That was produced somewhere else, in China. And so part of these dollar values, if we added them up, would be buying imported things. And so we just subtract them all rather than do it for each one of those bins. We just subtract it out as one big bunch. Part of the reason for doing that is we can measure that sort of thing relatively easily at airports and shipping ports, right? Boom, just right there. So that's the reason why it's net exports and we subtract out imports, right? It's because we're in the consumption, investment, and government spending, we're actually including goods and services from other countries that were purchased. The other part of this is from an income standpoint, it's got to be true that these are all equal ways. So the way you can think about this is from a principles of, I'm going to put up a different sheet here. This is from principles of macroeconomics. You don't actually see this diagram in your textbook, right? So we have producers over here. We have households here. Right? Households and producers interact with each other, right? Producers households get goods and services from producers, right? That's the C part, right? That's the consumption part. And households, so they what we're going to see in the labor market is they supply labor, right, to producers. They get income from the producers, right? And so producers are demanding labor. That's getting into chapter 3. So they get labor and actually, so let's put the arrow going that way. And they get wages, right? So producers pay households. Households buy goods and services from producers. Okay. Producers use the revenue that they get from selling the goods and services to pay the wages, right? Households then supply the labor, right? So there's a circular flow. Producers are producing goods and services and selling them in the goods market. Households are buying goods and services and supplying labor, right, to firms to produce things, and they get wages, which they then use to buy goods and services, right? So there's a circular flow of money. And then we have the government in here as well in the middle. Government's taking taxes and from producers, giving transfers, things like food stamps, SNAP, Supplemental Nutrition Assistance Program, and they're taking taxes from households as well, and giving some government subsidies to producers sometimes. So the government's involved in terms of taxing and spending, right? Government's buying goods and services from producers, right? So taxes and government spending. Producers are buying goods and services, capital in particular. Sorry, I'm letting Calvin back in. Firms are buying goods and services from, capital, machines, etc., investment, right? So we have C, we have I, we have G, and then we have other countries out here also interacting with the US, right? So they're acting with producers and households in terms of exports and imports. So that's kind of a graphical representation of our play, of our model, ultimately, which that we're developing in chapters 3, 4, 7, 9, and then the other chapters are kind of variations on that. So let me come back to where we were. So everything that is produced is accounted for in terms of expenditures. Everything, therefore, is accounted for in terms of income. There's a dollar flow into firms, people buying goods and services, that then gets used to pay workers, right? So there are wages, the rent payments, there's interest on loans. These are all different kinds of income in the economy. So in the end, when we talk about GDP, we're talking about income, we're talking about expenditure, we're talking about production, equally, all the same. So it depends on the context. So if we talk about GDP going up, we mean incomes are increasing. We mean there's more spending in the economy. I mean there's more production in the economy. All the same, right? So that's a key point in that first part of the chapter, that there are these three equivalent ways. It seems like and so there's an example in that first part of the chapter about orange ink and juice ink. That's actually an instructive little example. It's just a little pretend, a very small example. Two producers in the economy, producing oranges, and farmers producing oranges, and a juice company producing orange juice. But it makes this point. So last thing I want to say, well, let me say something about wealth and savings. That will come back into play in chapter 7 in particular. So we can measure the wealth of a country in terms of savings or borrowing and saving. Actually, it'll come into play in chapter 5 as well, when we bring other countries into our model again. We're going to leave them out, but we're going to bring them back in. So savings is simply what is left after whatever's left out of your income after you spend, right? And if there's savings in a given period, accumulated savings over time determine your wealth, right? So a question in chapter 7 ultimately is, well, how do people hold their accumulated savings, their wealth, right? When people are young, their wealth might be negative, right? Because it may own more than you own, right? In terms of your net worth, depending. Or somebody buys a house and they have to borrow, a couple $100,000. There's value in the house, but may or may not be as great as the actual outstanding balance. Might be, but it might not be. So savings is ultimately related to wealth in an economy, but we'll come back and talk more about that. So that's just kind of an introduction to that. It's kind of a separate, I would put that as kind of a separate issue. However, one of the things that is discussed in chapter 2 is this is actually important, the uses of saving identity. Right? We're going to use that over and over and over and over again. It's a really simple idea, but it's one that is really powerful and useful. We will talk about it almost every chapter. Not chapter 3, but probably. So it says that private saving plus government saving, right? Whoops, sorry. And we can derive this, and they do that in chapter 2, these accounting identities, these GDP accounting identities, right? You should pay special attention to that, but ultimately, it says national saving has got to equal investment plus the current account. That's really, it won't be obvious yet, but that's a really useful identity. It has to be true. It's identically true. Comes out of the GDP accounting. So what it says, for example, what it says, if national saving goes down, why might it go down? Well, because maybe government saving goes down. What does it mean for government saving to go down? It means the government's running a bigger budget deficit, right? Spending more. Stimulus checks, tax cuts, spending on infrastructure projects, which is what currently is being discussed in Congress, or will, yeah. And so if the left side of that equal sign, it's really an identity, so it's really identity, it's really 3, but it's fine, we can use just equals here, right? So if that goes down, it means something on this side has to go down. Just there's an equal sign in between, right? So what it says is reduced saving either leads to less investment in the economy or a lower current account. The current account is net, we're going to assume net factor payments and other things are 0. So just to make it simpler, that those are our net exports. Net exports going down. We already current account's negative. Right? We import more than we export in terms of goods and services in the United States. So it means becoming more negative, bigger trade deficits. So even without having the model behind it or anything, we're going to be able to explain why this is with our model. But, and this is in chapter 4 in particular, in chapters 4 and 5. But already we can see government budget deficits, bigger deficits, either lead to reduction in investment or a reduction or an increase in our trade deficit, reduction in our current account, or both, right? So things have ripple effects throughout the economy. We're going to see why that is. It has to do with interest rates, has to do with the real interest rate. Okay. So let me finish off with one more point on this chapter. And let's get to chapter 3, because there's a lot more going on in chapter 3 in some respects. That's the first part of our macro model. So why in macroeconomics? So if we had a question, why do we focus on real versus nominal variables? So in chapter 3, it's going to be the real wage. Here in chapter 2, it's real GDP or the real interest rate. Why? That was just a question I asked on the first exam, actually, this semester, the students in my class this semester. Right. Why? Why not nominal GDP? Why real GDP?
If you just focused on nominal GDP without accounting for the rise in the price level, any changes may be meaningless.
Yeah, we need to be a little more explicit about that. That's a true statement. So we need to be even more explicit about that. Give me an example.
Gross domestic product increases 10% nominally with a rate of inflation of 12%.
Yeah.
Many people, if you don't account for the real GDP, would look at that and assume it was good. In reality, it was actually a decrease in purchasing power.
Yeah, and actually not just a decrease in purchasing power, but a decrease in the amount of real goods and services that they have. So pizza, right? Let's say a really simple economy, we just have pizza. Pizzas cost $10 and we produce 10 pizzas. Nominal GDP is what? 10 pizzas, $10, right? 100. Value of production is 100. We assume that people eat them. If not, it's part of investment because it'll just be go into inventory, addition to inventory. If the price of pizzas goes up to $20 a pizza next year, and we still produce 10 pizzas, nominal GDP is 200, right? Mm-hmm. It doubled, right? How many pizzas do we have?
10.
10. Nothing's changed. You only have 10 pizzas. What do you care about? You care about pizzas. That's what you're going to eat. All right. So you got the same number of pizzas. We're not so real GDP. So in essence, that's really what is the case. The real GDP measures the stuff that you have, goods and services, right, in real terms. That pizza example is meant to illustrate it really is about the stuff we have available. This is a really simple example of that. Real interest rates are a little more interesting, a little not hard, but a little more complex to think about. Why do we focus on real interest rates versus nominal? Why should we care about the real interest rate versus the nominal interest rate? So why is it that let's see, let's crank up an example here. Interest rate 10% when the expected inflation is 8%. Oh, we'll do it this way. Is it better than the situation where we have 5% and expected inflation of 1%? Right. So let's say you're a saver, just to make it really explicit. You're going to lend money. You're lending money to somebody. You're going to get paid back money, or you put money in the bank. Either way, which one of these scenarios are you better off? Getting 10% when you expect inflation of 8%, or getting, remember, the I is the nominal interest rate. That's what you're actually going to get paid, right? Or 5% nominal interest rate when the expected inflation rate is 1%. I mean, I'm cooking.
Second.
Yeah, I'm cooking that up, right? All right. And so the answer is why? Well, the real interest rate here is I minus expected inflation. That's 2%. And your real interest rate here is going to be 5 minus 1%. It's going to be 4%. But thinking about what that really means in terms of goods, in terms of more goods, it's ultimately about more goods, right? So if you had $100, in this case, and let's say, let's use ice cream cones now instead. So ice cream cones, right? Ice cream cones, or let's say yeah, so let's say ice cream cones cost $1 today, right? How many, if you're lending money, you want to get some rate of return, right? The reason you want to get some rate of return is you're giving up the opportunity to use that money to buy stuff today and enjoy the consumption of the stuff today, right? So you're putting up satisfaction from consuming stuff today to the future, and you get some reward for that. That's what interest is about, right? That's the point of interest. You're putting off consumption, because consumption is a good, right? It adds to your utility in economic speak, right? So how many ice cream cones could you get? You could get 100 ice cream cones today, right? So now if we go to, so this is today, this is in the future. And if there's been inflation of 8%, ice cream cones, right? Ice cream cones now cost $1.08. That's 8% more, right? You get 10% interest on your money a year from now, right? In 1 year. So you're going to have, if you take your money out of the bank in a year, you're going to have $110. Ice cream cones cost $1.08, right? So how many ice cream cones are you going to be able to get, right? 110 divided by $1.08, and that's going to be more than 100. It's going to be should be about, it may not be exactly right, but should be about 102 ice cream cones. That's what the 2% real rate of return means. You get more ice cream cones in the future. What you care about is not dollars, you care about ice cream cones, right? Or put whatever you want. Let's just say I have my, I could, so 100 would be 100. That's about right, right? So 100 ice cream cones at $1.08 would be $108. 2 more would be $2.16. So it'd be 110.16 cents, almost 102 ice cream cones that we could buy with $110 when they're $1.08, right? So over here we have $100 again. In this example, we can get 100 cones today. In the future, if the ice cream cones aren't go up, inflation's 1%, ice cream cones cost $1 in the future rather than $1.08, right? And how much money you're going to have? 5% interest. You're going to have $105 a year from now. And you can, how many ice cream cones can you get? Well, if they're $1, it's
104.
Yeah, divided by 1.01. It's going to be approximately 104, right? It'll be off by 4 cents there, but right. So that's what the real return. That's what this real return means. That's what a real interest rate means. It's real. You get more real stuff, right? As a lender, it means you have to pay more in real terms, right? So you're better off, right? In this case, the real interest rate is what we care about, not the nominal, right? If you just look at the nominal, it looked like you were going to be better off with that higher nominal interest rate. Okay. We'll get to the real wage when we get to chapter 3. But that's all. So we want to focus on real, how do we measure things? Real GDP. That's what we want to focus on. We want to think about this in 3 different ways of measuring GDP. We want to think about real interest rates, how we measure the price level and inflation. Wealth and savings, we'll come back and we'll talk more about that, but that's kind of the starting point, and this uses of saving identity, right? Those are the big ideas in that chapter. Any questions about that? All right, it's just kind of foundational stuff, but it's going to turn out to be important. It's just sort of deceptively simple. Like, well, yeah, this is just measuring stuff, but yeah, later on we're going to be able to make statements about things because we know all this stuff in that chapter. So, chapter 3, chapter 4, chapter 5, chapter 6, and chapter 7. Chapter 6 kind of is different, and chapter 4 and 5 are connected, right? So I'm sorry, I'm writing. I'm not showing you what I'm writing. Okay, let's share the screen again. Sorry about that. Okay, what was behind the curtain here was chapter 3, chapter 4, 5, 6, and 7. They're all talking about the long run growth, long run model. So, yeah, chapter 3 talks about the labor market and the production function. Chapter 4 is about the goods market. Chapter 5 is simply an extension of the goods market with other countries. I'm going to leave 6 out. 6 is about long run growth too, but it's a little different. We'll get to that in a couple of sessions from now. Chapter 7 is about the asset market. those 4 circled pieces, the labor market, production function, goods market, asset market, that's our macro model. In chapter 8 and 9, in particular, chapter 9, we're going to bring all of those things together to talk about business cycles. We're going to, they're not new markets, but we're going to talk about something called the ISLM FE model. And we're going to talk about aggregate demand, short run aggregate supply, long run aggregate supply. Aggregate demand, aggregate supply. There's an introduction to this in chapter 1, but I'm going to even go back further. That's the model. That's the model that is discussed in Principles of Macroeconomics, ECON 201. That's the model that we talk about in that course. It's a course I teach too. Right? We don't do all this other stuff. What we do in this course, Intermediate Macro, is to show that that comes from all these other markets. So what we talk about in general in this macro, in this model that we're developing over these chapters, 3, 4, and 7 in particular, all right, is something that we call general equilibrium in the model, in the economy, sorry. Well, in the model too. So I'm just setting this up conceptually, right? Because you didn't see these other parts and get a good understanding about how these things connect to each other. So it's important to understand each one of the parts, but then it's important to understand how these parts interact with each other. So something happens in the asset market. That's where the Federal Reserve is going to come into play. For example, we'll see that in terms of the money supply. And that has implications for the labor market and the goods market. Something happens in the to affect the production function. We'll talk about that shortly. And that has implications for the labor market, has implications for the goods market and the asset market and overall in the economy. We want to be able to trace those things through all of those markets. So what I really want you to be able to do is say, oh, I hear in the news, I read in a blog post, I saw a tweet, I read a piece in the Wall Street Journal or the Economist, New York Times, I heard on the street that the Federal Reserve, that Jerome Powell, the chair of the Federal Reserve, is testifying before Congress, and he said, we're going to keep interest rates at near 0 for the next 2 years. What does that mean? Or alternatively, the coronavirus hits. How do we model what goes on in all these markets in the overall economy? Or we have vaccines and we reach herd immunity. What does that do? How do we model that in this economy? Or the government, the federal government, Congress and the president decide to write or pass legislation and put into law policy that sends checks to people's houses. Literally, almost literally, that's like a helicopter coming over and dropping dollar bills. Like almost literally, right? They just appear in your bank account or they appear as a check in your mail, right? It's like a helicopter coming in and just dumping buckets of money out, right? Literally. How do we model that in the economy? What's going to be the effect on real GDP, employment, the real interest rate, investments, saving, and the price level? Those are the variables in our model. All right. We'll be able to answer that question in a few weeks. Okay? And we're going to be able to answer parts of those questions along the way. So let me give you one other conceptual idea, and then let's dig into chapter 3. There are sort of 3 ideas in chapter 3, big ideas. So if we were on campus and we were at probably the first day of class, in my class, I would hand out and have a graph. And it would represent over time, calendar time on the horizontal axis, and it would be real GDP. In the US, right? US real GDP, right? So what would that graph look like? I'm gonna actually flip it around. I could ask it that way. We could have it blank and you could tell me. Oh, but I'm gonna show, if we actually just plotted the data, we have the data from the Bureau of Economic Analysis. Federal Reserve of St. Louis actually has a really nice tool, Fred. You had actually had that. You were doing work with that in the class last semester, right? You had to do these. You had to create a
Dashboard.
Dashboard. Thank you. That's the word I'm looking for. Yes, I knew where I was going. Thank you. One of those dashboards would have been real GDP, right? So what does it look like?
It's a gradual general uptrend.
That's half of it. That's half of it, right? So it looks something like this. Yes, so that's half of it. And I would ask the question in class, so what are the 2 things that you notice about this graph? One is the one you just said, right? General upward trend. What's the other one?
It's not always. It doesn't always increase.
Doesn't always increase. Ups and downs, right? There are ups and downs, but the general notion is up. So, duh. That's like, okay, big deal. Like, yeah, that's pretty clear. That's pretty straightforward. That graph is the whole course in a nutshell. That is the whole intermediate macroeconomics course in one graph. That's the whole deal. That's it. Everything else is details. I mean, the details are really important, but if you conceptually you understand that, everything else fits into place. And you can, in other words, every one of these chapters that we talk about, you can put it into some place here in Rasmussen's graph. So if I just want to show the long run economic growth trend in the economy, I just have if I just want to focus on that, I can just kind of put a line through there that represents the trend growth, right? You can actually do that mathematically, right? And statistically, right? So that's what we talk about, the long run growth, right? That's this we're talking about. That's chapter 3. That's chapter 3. Chapter 3 is what determines the long run growth trend of the economy. We're going to come back to that in chapter 6, but it's chapter 3, right? The other line here, so that's the trend. This is the actual level of real GDP that we measure every quarter. You can see that some periods of time, right? Pick 2008. I don't know, I'm just picking that, right? So pick 2008, right? The actual level of GDP is less than, right? We measure that on the on the vertical axis. So this is Y actual. This is Y long run. We have a name for that. It's called potential GDP. Where would the economy be if we were at full employment? Called potential GDP. Chapter 3 is about what determines potential GDP. Okay. What determines this long run trend? Chapters 8 and 9. Chapter 9 is about business cycles. It's what causes us to be away from the long run trend, either above or below at any given point in time. And the question is, if we find ourselves below long run trend, this is called a recession, contraction, a recession. Is there anything that we should do? We, meaning the Congress, President, Federal Reserve, policymakers. Is there anything policymakers can and should do or not to try and bring the economy back to full employment? Or should we just let things take care of themselves? So, for example, with the coronavirus pandemic, lockdown in the economy, huge reduction in real GDP, the greatest since the Great Depression, all right? But not of the same magnitude nor length, but a significant decline in real GDP, significant recession, a sharp recession, although short-lived. It was deemed important that the government, Congress, and the president get involved to try and move the economy back to full employment. Like those have been the headlines. That's what. It doesn't matter whether it was the Trump administration, doesn't matter whether it's the Biden administration. They both have said the same exact thing about that, right? And Jerome Powell, the Federal Reserve, has also said the same thing. Federal Reserve policy, fiscal policy by the federal government, Congress and the president, have been aimed at, and these stimulus checks in particular, this is now the third round of them. The first, actually, the third round of them have been aimed at getting the economy back to full employment. Right? The infrastructure discussion that's happening right now in Congress, spending more on roads, bridges, highways, ports, broadband access, broadband backbone for the economy. Those are aimed at kind of both getting people, creating more spending and more jobs, but really trying to influence the long run trend of the economy. All right. So how do we get these fluctuations to happen at higher levels of real GDP? So macroeconomics is about the long run growth, business cycles. What can the government or Federal Reserve do? What should they do or should they not do? That will depend on assumptions about price flexibility and wage flexibility ultimately. To A, try to get the economy back to its long run trend, and B, to affect the long run trend itself. That's the whole course. That's it. In one picture. That's the whole course. But if you can have that as your outline, your frame of reference, everything else fits into that picture, right? So it's really important to understand that, right? Conceptually, and that's not something that's sort of written out exactly that kind of picture in the textbook, right? But that's the idea, right? As an economist, that's the way I view everything in this course. And I can quickly zero in on which piece we want to think about. All right. So let's spend the rest of our time here today talking about chapter 3. Chapter 3, production function for the economy and labor market. Labor market, labor demand, labor supply. Production function. deals with what causes the long run growth of real GDP? What determines the level of real GDP at any point in time? Right? So we say, we conceptualize this in the following way. All right? Oh, real GDP, why? Is a function of labor, the amount of labor, the amount of capital, and this thing A. What is that thing A?
Total factor productivity.
Total factor productivity. Why do we call that total factor productivity? So, because you tell me the level of labor and capital in the economy, and just keep that fixed. So the same amount of labor and capital, or a given amount of labor and capital with a given amount of total factor productivity can produce a certain level of GDP. That's what that says. That's just in words what that says, right? Now, let's keep the level of labor, level of capital the same, but A increases. What's going to happen to Y? It's going to go up.
It's also going to increase.
Yeah, it's going to increase, right? That's just mathematical. There's an equal sign there. So A is like an enhancer, like fertilizer. It's like a multiplier. It's like so it affects both labor and capital together. Factors of production, labor and capital. So it affects the total amount of those factors, total factor productivity. It's not just labor productivity, not just capital productivity, it's total factor productivity. What do we usually associate with A? What's the common
Increases in technology.
So technology,
Infrastructure.
could be infrastructure, education, all right? New technology, could be machine learning, AI, for example, right now. Oftentimes new capital is also embodied with new technology, or vice versa. You can think about it either way. So you could have new, faster computer chips that embody new technologies that internally, etc. All right. So so normally we think about this in the following way. We'll use a specific to make the point here that we want to make. We'll use a particular functional form of that production function. When we get to chapter 6, I'll come back and talk about this, where these numbers, why this is 0.3 and 0.7, right? Why those numbers are what they are. Those are estimates from a regression equation, actually, from data. And so they're not just sort of picked out of the air. You notice that they add up to 1. We call this a Cobb-Douglas production function. Used in microeconomics as well. We can use it in macroeconomics. It has some nice properties. We'll get to that more when we get to in chapter 6. It's critical that those are less than 1. Why?
That way, if you it'll demonstrate a declining rate of marginal utility.
Yeah, in this case, not utility though.
Oh, not utility, sorry. Drawing a blank.
Diminishing
marginal returns.
Marginal productivity. Yes, that's right. It's productivity. Diminishing marginal productivity of what? Of labor and capital. So what does that mean in words? That is, well, we can draw the picture. So if we draw this graph, like we could do this in Excel. You just pick different levels of n, right? From 0 to 1,000,000 or 1,000 or whatever. You can just put numbers in. And so we have to make some assumptions if we're going to draw a picture in 2 dimensions, right? A 2-dimensional picture only has 2 things that vary, right? But we got 1, 2, 3, 4 different variables here: y, a, n, and k, right? So we got y and n. So what are we assuming about a and k when we draw this picture? They're constant. They're constant, right? So we'd put a little 0 there, a little 0 there to indicate that they're constants. So if I do that, then it's just y equals a0 K0 to the 0.3, those are constants. That's just a number. That's just a number times n to the 0.7. Okay. So that's just y equals, I don't know, alpha times n to the 0.7. Alpha is just some number, A0, K0 to the 0.3, right? Those are just fixed. So it could be 2 or 0.2 or whatever. It's just a number. So if I draw that, it's going to look like what? It's not going to be linear. It's not going to be upward sloping because it's less than 1. It's going to have a shape like that. And that's going to be important. So goes through 0. That's another important point, right? No labor, n is 0, y is 0. No employment, no output. We don't have machines to sort of run themselves according to that production function. So this is y equals A0, K0 to the 0.3 times n to the 0.7. It looks like that because of the 0.7, right? And you can, like I said, you can plot this. You can just pick a bunch of number of things. You can make this number. You can make this number 1 if you want, and you could do it in Excel. You could just make 2 columns, y and n, and y equals 1 times n to the 0.7, and just pick a whole bunch of n's from 0 out to 1,000. By 1s, by 10s, by 100s, whatever you want to do, and plot that, and that's what it looks like. Okay. So what do we notice about that? When n is low, when n is a small number, 10, let's pick a number. If we measure the slope of this line at that point, we measure slopes by rise over run, so we can just kind of do it. We can make a triangle, right? If we want, just with that tangent line there, rise over run. And we take a point out here where n is high, n is big. And we can take the tangent line there, right? That's the slope at that point, right? If we were doing calculus, we would just take the derivative of this, boom, right? Simple. We don't require Math 112 for this course, but right, that would just be I'll come back to that. It would just be the derivative of this function, all right, with respect to n. But we can see from here rise over run. Well, I mean, we can see that the rise, so the slope is rise over run. All right, over here the rise and run are about the same. Over here rise is much less than the run, and so right, the slope is low. Slope is low. Here, slope is high, big. Well, that's just, so what is the slope? The slope is the rise, the change in y over the change in n. How much additional output you get from an additional unit of labor? What's that called? Marginal product of labor. Okay, marginal product of labor. So what can we say about the marginal product of labor as n increases? Well, if it's the slope, the marginal productivity of labor gets less, right? So I'm going to come over here. I'm going to graph n and the marginal product of labor. So when n is low, right, from over here, the marginal product of labor is high, right? When labor is high, the marginal product of the slope, the marginal product of labor is low. Right. We can connect the dots, and it's going to look like that. So there's the marginal product of labor curve, right, as a function of n, holding capital and technology total factor productivity constant. Now, what would cause, so everything we do in this class is about how do we draw a curve, why does it have the shape it does, and what causes it to shift. That's it. I mean, we got to understand the economics behind that, but we'll get more to that in terms of how we make that into a labor demand curve, right? But in a second. But what would cause the marginal product of labor curve, right, which is measured on the vertical axis, so that's up and down, right, vertical, what would cause that to go increase or decrease? Same level of labor now it becomes more productive, can produce more per hour. Well, what we know from production function is for a given level of employment, what could produce more be an increase in K or an increase in A. All right, so an upward shift of this whole, no matter what the level of labor is, an upward shift of this would be either from an increase in A or an increase in K. Right, that would increase the marginal product of labor curve overall. Every level of labor now. What does that mean over here? If you increased A or K, it does what? It shifts that production function up, right? So that would be an increase in A or an increase in K. Would do that. What does it do? At every level of labor, it changes because it goes through zero, it changes the slope, right? So it increased, so the same level of labor now has is more productive. The slope is, it's harder to see that perhaps, but the slope is greater. The marginal product of labor is greater. Okay. So let's think about this now so we have the marginal product of labor, we have N. Looks like this. I'm just repeating what we had over there on that last page. My claim is that this is the basis for talking about labor demand. That's not labor demand by itself right yet, though. What else do we need? What do we need to change that into a labor demand curve? An assumption. Who's demanding labor? Firms, right? Remember our actors in the play. Households are suppliers of labor. We'll get to the supply of labor in a minute. Suppliers of labor. Firms are demanders of labor. What do firms want to do? They want to maximize profits. So how do firms maximize profit? Well, we learn in principles of microeconomics. They produce up to the point where what's true? The marginal benefit is just equal to the marginal cost. In this case, they hire labor up to the point where the marginal benefit of hiring one more worker is just equal to its marginal cost. So what's the marginal benefit of hiring one more worker? They get more output, right? They get more stuff. All right. So that's the marginal product of labor. That's the benefit. That's the additional output they get from hiring one more worker, which then they can sell at some price times that, right? So if they can get 10 more pizzas produced and the pizzas are $10, their marginal benefit of hiring that worker is $100 worth of stuff, $100 worth of revenue. What's the marginal cost they have to pay? What's the marginal cost of hiring that additional worker? It's the nominal wage that they have to pay that worker. So we can change this around, say, they hire workers up to the point where the marginal product of labor, the additional output, is just equal to the real wage, W over P. We care about the real wage. Workers care about the real wage. Firms care about the real wage. What's the real wage? If we just take the units involved, W divided by P, capital W divided by, so wage is dollars per hour, right? Prices are dollars per, I don't know, pizza, dollars per good, right? So we have a fraction over a fraction. We know that we multiply the middle part and we multiply the outer part. And so this is dollars times goods divided by dollars times hours. The units cancel out. The real wage is in terms of goods per hour. The real wage is what workers care about. How much, not just how much they're getting paid in dollar in actual nominal terms, but also relative to the price level. How many goods they get for an hour's worth of work. The same is true for the marginal product of labor, right? What firms care about is how many goods. Now, they don't just care about how much they're paying their workers, because they also care about how much they can sell their products for. What they care about is how many goods can be produced per hour of work. Okay, so why does this matter? So you tell me, so we're going to assume the real wage is given. We assume competitive markets. So there are some assumptions going on here that may not be true, right? But if we assume perfectly competitive markets, wages are given to the firms. Firms take the wages given, and they can hire as many workers as they want up to maximize profits. Price levels given, right? So the real wage is given. So you tell me the real wage, and the question is, how many workers am I going to hire? Am I going to hire the first worker? Yes, the marginal product of that worker is greater than the real wage. The marginal benefit of hiring that worker is greater than the marginal cost. Yes. When am I going to stop? When the marginal benefit is exactly equal to the, in other words, the marginal product, right, is exactly equal to the marginal cost, right, whatever that is. I'll let N0. Amount of labor demanded. Pick a different real wage. Higher real wage. Do the same thing over and over again, right? That's how many they're going to hire. Would they hire more than that? No, because if they went out to N0 rather than N1, right? At N1, right, the marginal productivity of the workers down here, but they got to pay more than that. No, that wouldn't. They would not be maximizing their profit. Then they'd want to go back the other direction, right? So every real wage, with the assumption of profit maximization, it picks off a different point on this marginal product, the labor line, and it becomes labor demand, and this becomes the real wage, since real wage in equilibrium is equal to the marginal product of labor. That's what we have over here. So labor demand, real wage, employment. Shifts in labor demand have to do with changing capital or changing technology, because that makes, in general, we think about that shifting to the right or up, because that new technology will generally increase the productivity of workers. All right, that's half of our market. All right, so labor supply. All right. The argument's going to be that labor supply looks like this. So labor market is going to have the real wage and labor. This has got to have the same thing. So the argument here is that I'm going to, at higher real wages, people, us, households, supply greater amounts of, right? Real wage goes up, higher amounts of labor supplied. That's the argument, right? Why? And then what causes this to shift, right or left, right? More labor demanded, more labor supplied, right? So different issue, right? Labor demand has to do with profit maximization. profit maximization decisions by firms. What does labor supply have to do with?
Trade-off between income and leisure.
That's right. So it has to do with utility maximization. And we assume that consumers, households want to maximize utility. They do that through more goods and services. The good here is leisure. All right. So the decision is about how much leisure to consume. Okay. And what affects that decision? The labor supply is 24 minus the amount of leisure consumed. All right. Because there are only 24 hours in the day. So labor supply, we aren't making a decision directly about labor supply. We're making a decision, the economic theory is that we're making a decision about demand for leisure. By determining that, because we know something about demand, what affects demand for goods and services, demand and supply, then we can just sort of back out what it means for labor supply. So if you demand more leisure, it means you're supplying less labor. If you demand less leisure, then you're demanding more, or supplying more labor. All right, so utility maximization by consumers. All right, maximize utility by choosing how much leisure they want. So leisure is the good. It has utility, has value. We value that. Labor supply doesn't. We get labor supply by subtracting out the leisure from the 24 hours in our day. So we know about the things that affect demand, right? So demand for leisure. Demand for goods and services. So we learn about this in principles of micro and principles of macro. What are things that affect demand for goods, for things that have value, right? Current income, expected future income, right? Those are things that matter, okay? In this case, the price of leisure, right? The price of leisure. And what's the price of leisure? It's the opportunity cost of what you could do with that time. If you were not consuming leisure, you could be earning money, right? And so the real wage measures the price of leisure. Okay. We got to get the real wage in here. Your things, like you could go back to principles of microeconomics, macroeconomics book, and you can see these are the things that affect demand for any kind of good, right? You learn about that in a principles course in early part of a course. And so it doesn't matter whether it's demand for cars, demand for hamburgers, demand for gasoline, demand for whatever, right? These are the things that affect demand for things that are for goods and services. What's the good that we're just happen to be looking at is leisure here, the market for leisure, right? So the argument is that as the real wage goes up, the quantity of labor supplied increases, the quantity of leisure therefore goes down. All right. So that's the hypothesis, right? As the real wage goes up, right, we supply, there's an increase in the quantity supplied of labor, which means that there's a smaller quantity demanded for leisure, right? They're just two sides of the same coin, right? So if this is if leisure is L, then this is 24 minus L, 24 hours a day minus the amount. But this is the choice that consumers are making. And the labor supply falls out of that. Right, so that's the null hypothesis that we're going to work with. So why this is the price of leisure. So why, right? So one of the things we know, right, for demand curves generally, price and quantity, right? As the price of something goes up, people demand less of it, right? That's just that's what it means for there to be downward sloping demand curves, right? That's right. So as the in this case, the price is the real wage, and this is the amount of leisure being demanded, right? So that's what we're saying. As the price of leisure goes up, there's less quantity demand. It means there's a downward sloping demand curve for leisure. All right, but we have a little bit of a sticking point. We could do this in terms of the graphs in the textbook. They don't actually do this in terms. They actually do it in the no, they don't actually do it in the appendix. But we could do it in terms of looking at the microeconomics of the demand for leisure, budget lines, utility isoquants, right? Utility maximization curves, right? We don't do that in this course. We could, but we talk it through. They talk it through in terms of words. And so there's this thing called the substitution effect, right? And the income effect, right? So the substitution effect always works in one way, right? So it says as the price of something, the relative price of something goes up, we tend to substitute away from that into other things, right? So at the margin, as the real wage goes up, the opportunity cost of staying in bed an extra hour, right, goes up. What you're giving up by consuming more leisure is more expensive, right? You're giving up more stuff when you know, if you got paid $1,000 an hour versus $10 an hour, like you might question whether I'm going to sleep that extra hour. Like I want to work to get that, right? So I'm going to tend to choose less leisure and supply more labor in that case, right? So substitution effect says, as the real wage goes up, I'm going to demand less leisure, and therefore I'm going to supply more labor. All right, moving in terms of labor supplies. That's the basis essentially for, that's essentially the basis for this labor supply curve. But we do need to take into account the fact that as the real wage goes up, what's also true, you don't need to work as many hours to hit a target level of income, right? If you got $1,000 an hour versus $10 an hour, to take a really extreme case, you don't need to work as many hours to, you know, get to $1,000, right? You only need to work 1 hour. So you're going to tend to work less. So this tends to go in the other direction, right? You're going to tend to supply less labor due to the income effect. So the question is, which one dominates? And we assume that the substitution effect dominates. So you get upward sloping labor supply curve. Question is, what causes that to, what causes people for a given real wage, then what causes people to either supply more or less leisure? The relevant question is, what causes consumers to either demand more leisure, supply more or less labor? The relevant question is, what causes people to either demand more leisure or demand less leisure? Well, we can just go back to these things. If you expect, for example, if you expect future income to go up, what are you going to do today? Well, you know, you can earn more in future. You can take more leisure, right? And so it probably it may, or your current income. Let's do that, right? If you're going to earn more income today, maybe you supply less leisure, supply less labor, demand more leisure, right? As income goes up, you generally demand more of something. Right? As your wealth goes up, you generally demand more of something, right? So you win the lottery, right? You're probably going to demand more leisure, supply less labor, not going to work as much, right? On average, at the margin, right? So those are things that can affect and shift the labor supply curve for a given real wage. All right, let's put this all together. So we have the way to think about this: the production function, N and Y. We have, right, can draw the picture right below it, right, because we're using the same axes, N and the real wage, labor demand, labor supply, production function, Y equals A, I'll put K0, we'll assume that that's fixed. Those are constant, right? Times N to the 0.7, diminishing returns to labor. Together, labor demand and labor supply determine this is what determines full employment. Okay. In a competitive market, that determines the real wage. That's equilibrium, let's call it A. Once we have this amount of employment, call it, we'll put a bar over that, that's full employment. Full employment simply means there's no shortage or surplus in the labor market. We can just we can go straight up at that level of employment, just keep going straight up. That's the amount of output we can get. Put a bar over that because that's the amount of output, real GDP we get when we are at full employment. What do we call that? Potential real GDP. Go back to this picture that I drew earlier. All right, that's the trend growth. Chapter 9, we'll come back and say, like, we aren't always there. We aren't always at full employment. All right. So this is what happens in the long run. This is our long run model. The assumption is eventually we get to equilibrium in our markets. Prices and wages will adjust to bring about equilibrium in the marketplace. That's the assumption. Long run, not the short run, not what happens week to week, month to month, not even year to year, but over 5 years, 10 years, 100 years. Okay. So what we can ask a bunch of interesting questions. So, for example, what would you expect to happen? Well, no. Let me ask a more general question first. All right. We got about 15 minutes remaining. So if we care about long-run economic growth, we care about long-run, what causes GDP? What causes potential GDP to grow over time? According to our model, what causes this to grow over time? What could cause that to grow over time?
An increase in total factor productivity, an increase in capital stock, or an increase in the labor supply.
And how does that show itself in the model graphically? So if there was a shift in the labor supply, all right, what would happen? I don't want to draw it on here yet, but because I I'm going to do both. I want to talk about both, but conceptually, we can figure this out.
An increase in the labor supply would cause the NS curve to shift to the right.
Yes, and keep going. Finish that out.
It would increase the total amount of labor supplied and decrease the real wage.
All right. So
It would also lead to higher production.
Yes. If we go up along the curve, right? Which means more real GDP, right? That's economic growth over time, right? So an increase in labor supply could cause real GDP to grow over time. So the question in the real world, what could cause that to happen? In addition to the things we just talked about, the things that affect labor supply are things like population growth, birth rates and death rates in a country, immigration policies. All right. So what do you think's happening? So generally, right, populations are growing over time. Question isn't whether they're growing or not. It's a question, it can't, well, let's just say that. Yeah, generally that's the case. The question is, how fast are they growing? That's the question. So what's happening to the labor force in the United States?
It's aging.
It's aging, right? Demographics. So is the labor supply increasing? Is the population increasing in the United States? Yes. Is it increasing at a slower rate? Yes. It doesn't, in other words, it's not going to shift out as fast in the future. Isn't shifting out as fast now as it did before. And what does that mean? That means employment doesn't increase as much. That means GDP doesn't grow as fast. Standards of living don't grow as fast. We'll come back to this in chapter 6. It's been the case over the last 70 years or so that GDP has grown about 3% on average per year. And so if that goes down to 2% per year or 1% per year, it means that standards of living don't grow as fast. So generally, it's been the case that standards of living have generally doubled about every generation. In other words, your standard of living at the same time that of your parents at the same age, not for each individual, for the overall average in the macroeconomy, it's about double what it was in real terms, like not just in dollar terms, right? But if the growth rate slows down, it means that maybe your children's standard of living isn't that much bigger than yours right now. That would be a huge change historically. Why does that matter? Because why does every politician, why does every president care about GDP growth, real GDP growth? Because if the pie is growing, right? GDP pie, pizza pie. If the pie is growing, everybody, in theory, can have a bigger slice. Does everybody get a bigger slice? Not necessarily. But in theory, everybody can have a bigger slice. Everybody's standard of living can go up. Everybody can have more pizza than they did before. But some people are going to get a way bigger slice of pizza, and some people are just going to get a little bigger slice of pizza. That's a different question, right? And that's about income distribution. That's not the one we're going to talk about here right now. In reality, that matters. But if I can tell you, if the pie is not getting bigger or not very fast, that means if somebody gets a bigger slice of the pie, that means somebody else gets a smaller slice. And if that happens, That's what leads in the world. And historically, that's what leads to revolutions, coups, overthrows of government, etc. Nobody wants that generally. So it doesn't matter whether you're a Republican, a Democrat, an independent. If you're president, you want to grow the economy. Now, Republicans and Democrats, independents are going to have different ways of trying to promote that, but they all want that. No different. No, in the United States anyway. Right? That's historically been the case. Maybe that won't be the case in the future. Maybe we'll talk about what matters is the distribution of income and not the size of the pie. But if the pie isn't growing or not very fast, it means if somebody gets more, somebody else is going to get less. If the pie is growing, everybody can have a bigger slice. This is why in China, right, Xi Jinping is really interested in growing the economy at 6% a year, 7% a year. It leads to less unrest, right? So if the economy is not growing very fast, that's what leads to unrest, social unrest in countries. One of the things that leads to social unrest in countries. So aging population, that brings some challenges. Labor supply. So what has to offset that? Either there has to be a greater fraction of younger generations that come in, that younger generation that comes into the workforce than was in the workforce previously, or you got to find it somewhere else. Okay. It's one of the flip side of that is increasing the labor force participation rate starting with World War II, and then following that in the post-war period, post-war meaning since 1945 or so. The labor force participation rate of women, which started really to increase in particular during World War II, as many men were off to war and they needed increased production, right, of goods and services and tanks and food and whatever, right? That was huge. That was a huge change in how we think about work. And that was a really big increase in the labor supply ultimately, right? We have the difference between labor force participation rate of women and men is not dramatically different today. In 1945, it was significantly different. That was a big boost to the economy, helped the economy to grow post-war as well. So that's one way we can move along. So in terms of the graph, we can move along the production function, and that leads to more increased potential GDP. That would be coming from a shift in the labor supply. Another way you could offset a declining labor force participation rate in the economy as people age out, people like me, over the next decade, let's say, right, retire, maybe, and is increase immigration, right, to make up for lower birth rates in your own country. So the flip side of that is, if you want to limit immigration, you're limiting labor supply. Labor supply is not going to grow as fast. Okay. There may be other reasons that you do that, but it has economic implications. There are trade-offs in that case. At the end of the day, though, right? So that's what happens if you increase N, right? Holding capital and total factor productivity fixed. What happens if you increase the amount of capital that workers have to work with? What happens if you increase technology? How do we represent that here? So yeah, go ahead. So I'm going to take out instead. I can't just erase this. I'm just going to pretend that we didn't do that now, or we're going to look at a different one on the same graph. All right. Go ahead.
So that will shift the marginal productivity of labor up, leading to a higher real wage, more employment, and a higher potential GDP.
And this, why does the marginal product of labor increase, or labor demand in that case? Because higher increase technology, right? Increase in A for a given N does what? Shifts this
Allows people to
curve,
work more.
shifts this curve up, right?
Mhm.
So this is Y equals A1, K is 0 to the 0.3, N to the 0.7, where A1 is bigger than A0. Total factor productivity is increased, maybe because of an increase in technology. Some countries it could be because of an increase in literacy rates, education literacy rates. Could be increase in the number of people with college degrees. Right? Could be any of those things. So that's the first thing that happens actually is the production function shifts up. So that's number one. Number two, what does that mean? That means the slope at every point for every N, the slope on this new production function is bigger, which means the marginal product of labor is bigger, which means this curve has shifted out, right? More labor demanded at every real wage, because now the workers are more productive. The firms are profit maximizing. Now the marginal product is, the marginal benefit of hiring another worker is greater than the marginal cost. So they hire more workers. So in the end, right, new equilibrium at B. So this is number 2 in the sequence. So at B, we end up with more workers, higher real wage. All right, so I'm using the same line here actually that we did before, higher employment, more workers working. What's different? We are up here, not here. We are up here. We're in a new production function. You get an even bigger boost in real GDP, higher growth rates. So we move from here to there, not just there, but all the way up to here. We get a double boost. We get more employment, which is a move along the production function, and that those workers are more productive, both. Double boost. At the end of the day, boosting up that trend line, increasing living standards ultimately for people, depends on increase in total factor productivity. That's critical. It's critical. That, at the end of the day, is the deal. I don't know if you're going to say something there, Calvin.
Oh, can I ask a question?
Yeah.
So post World War II, what has been the main driver of economic growth? Has it been a higher labor force participation rate, an increase in the capital stock, or an increase in the or an increase in total factor productivity as a result of technological innovation?
Yes. It's all, but I mean that it's all those, right?
Mhm.
So a different way to ask that question to make that point is, when we get to chapter 6, and I can point you to it now too if you want. I'll point you to the Congressional Budget Office every January, actually twice a year, comes out with projections for long-run growth in the economy. And it's actually directly related to the material in chapter 6 that we'll cover, called growth accounting. And it does exactly that. It looks at that question. What's been the main driver? And in the past, it's been kind of all of those. But going forward, what we know is that on the labor side, that is not, according to current demographic trends, that is not going to continue like it has in the past. Increases in capital could increase or not. And so the fact that one of the three is going down in terms of percentage changes, not negative, not declining, but the growth rate, right, means you have to offset that by an increase in total factor productivity or capital, as you're kind of indicating. And total factor productivity has varied over time. but it slowed down. Slowed down. So that's the deal. And so ultimately for policy, if you care about that, maintaining the kind of historical growth trend about 3% a year or even higher, then you have to ask the question, well, so what are the reasons why it may have slowed down? And B, can we do anything about that through tax policy, government spending? That is what is behind, in economic theory, that is what is behind the infrastructure bill that's being discussed in Congress right now. That's absolutely 100% what's behind that. It's a mystery to me why there was not an infrastructure, why an infrastructure bill was not one of the first things that the Trump administration did when it came into office. Hillary Clinton and this may sound odd. Hillary Clinton and Donald Trump, when they were running for president, both favored infrastructure bills, increase in infrastructure spending. It's a no-brainer in a sense. Republicans and Democrats both agree. Now, what exactly you spend the money, what infrastructure you do, that's the contentious part, and that's the part that the Republicans and Democrats will haggle about in Congress now, and they would have 3-4 years ago as well, right? But conceptually, Democrats and Republicans are all in agreement about this. It's in the details, and the details matter, right? The devil's in the details, but it's a bipartisan win for in general. It's kind of a mystery. Anyway, that is absolutely right. The economists on the Council of Economic Advisors, the advisors to the president, this is the conceptual model that they have in their mind. That's what's behind the legislation. Right? This is the way economists thinks about that. But it's exactly what's behind that. Right? So if you're going to have increases in living standards, if you're going to grow the pie, if you're going to grow real GDP, ultimately it has to be about total factor productivity. It has to be about technology, it has to be about infrastructure, it has to be about human capital, right? You could think about capital and human capital or physical capital. It has to be about education. It has to be about that's how it translates into what's happening in the real world. So our job in a course like this is to be translators. I want you to be able to translate both ways. I want you to be able to translate. So the exam questions I generally have, and I'll provide you examples of those as we go along here and what that looks like, are invariably, and homework questions that I have, are invariably, here's what's happening in the real world. Use our model to explain that. Bottom line, all right? So my current class is in the chapter, they're having an exam on Thursday on chapters 5, 6, and 7. Chapter 6 is about long-run economic growth and exactly these things that we're talking about here. I can tell you 100%, I tell them this, right? They will see a question that will be related to the current discussion in Congress about the infrastructure spending. From Wall Street Journal articles. Just this morning I was reading. I mean, it's almost every day. There's a piece about that. Right? I want them to be able to translate that into the theory. And the flip side of this, it translates back again. Here's what the model says. Yes, here's what you would expect. So it could be that you're a legislative aide, and if you campaigned, your boss, your big boss, the president campaigned saying, I'm all for increasing economic growth. How would you use your economic theory to provide counsel about that, right? So in the short run, maybe it's things like the stimulus bill. Long run, and so maybe the question is, long run, how would you spur long run economic growth? Well, that's translating the other way. How do you translate the model? We know what things, the factors that affect long run economic growth from our model. How does that translate into actual policy and actual real world stuff? You should be able to go both ways. Right? So that's an important key learning outcome when I teach this course. Right? Because that's what you could be asked to do in a company, in a government agency, whatever. That's what economists do. So what can we? So if there's an increase, let me just finish off with this, because it's another kind of interesting way to think about this, not just from the economic policy standpoint, but just from what's going on and what we hear about in the news sometimes, etc. So an increase in technology. What kind of increase in technology? What about? So I could make that more specific and say, how would you model an increase in artificial intelligence, an increase in machine learning, and the use of those in production? Well, what is that? That's an increase in A. Maybe it's related to an increase in K too, but okay, that just adds to the story. That it doesn't change conceptually the idea, right? That's an increase. So the translation is, oh, that's an increase in A. If there's an increase in A, that's just a production function. If that happens, that's just labor demand up and to the right. And now, right, the question is, what do we see? An increase in, so what would we expect to see from that over time? An increase in employment, an increase in real wages, an increase in real GDP. Like, that is the best of all possible. This is the best of all possible worlds, right? Economically, macroeconomically, right? We get higher real wages, right? Not just higher money wages, but higher real wages, more pizza, right? For an hour's worth of work. We get more people employed, and real GDP growth rate is increasing. Now, there are other questions about sustainability and climate change and all these other things, right? That's to do with the assumption here is that that's not being affected. Now, if those assumptions are changed, then we got to change our model, right? But this is the base model that we start with, and we can add those other complexities in to think about that. But you oftentimes read in could be a blog post, it could be on the news, it could be in newspaper, right? An increase in AI, increase in robots, use of robots, right? Industrial robots, right? To produce things. What's going to happen? That's going to take away jobs. People are going to lose jobs. What happens? We just have robots. What does the economic theories tell us? No. We're going to have more employment, right? So that should, and you should say, well, wait a minute. That should cause some dissonance when you read something like that. And you say, well, why are people writing that? Well, because some people are going to lose jobs. Yes, they are, right? We're not going to need as many accountants, for example, right? Many of the accounting, one of the basic accounting things that we teach students, right, as undergraduates, are going to be obsolete in the next 10 years, 5 years. They are already in some respects. So we have to change how we teach people. We have to change how we teach all of you as well, because it's not about the actual, and accounting is an easy one because like, it's just stuff. It's mechanical stuff. Like it's just, this is what you do. There are rules about that. Well, machine learning and AI can do that really well. We can program that really well, right? What it's not as good at right now is making sense of the results from that and decisions that need to be made. That's going to happen too, and is happening. But that's where, so that's why in a course like this, and I'll just kind of, that's where I'm kind of finishing up with that, that's why the benefits of, that's why this kind of course is aimed at trying to build your analytical thinking processes so that you don't get replaced by a machine. So the way one way to think about this is, yeah, back 100 or 200 years ago, right? we could, you know, we don't have as many farriers as we did then. Farriers are horseshoe people, right? For horses, right? So yeah, when automobiles came along, did farriers lose jobs? Absolutely, right? But those railroads created a whole bunch of other kinds of jobs that weren't there, whether it had to do with the logistics and loading things, whether it had to do with engineers, whether it had to do with putting down railroad rails. So in the short run, it does cause pain for people whose jobs might get replaced by technology. But that technology also generates a whole bunch of new jobs. Then the question is, what can we do about that so that the people that get hurt by technology, maybe in their 55 years old and they lose a job because now production went somewhere else where it's automated, you know, to help them along. Maybe it's retraining in community college, maybe it's payments, whatever. I don't know, but that's a different question, right? That's a political question. So we can answer a lot of really interesting questions with a really simple model. So that's really chapter 3. And chapter 3, you can kind of think about this, compartmentalize this in a sense by itself. This labor market production function, that's what determines potential GDP in the long run, period. Nothing else matters. So it only matters to the extent that the other things, government policy, et cetera, affects labor supply, labor demand, or the production function.
Could rapid technological change lead to a temporary uptick in structural unemployment?
Sure, in the short run, absolutely. That's what I was just saying. Yeah.
That makes sense.
Yeah. So it might take a generation to filter itself out, right? They're different. You know, we have way more employment today than we did 50 years ago. Jobs are different, right? Jobs are different. People adjust. This is a long run model, right? We're talking about what happens over decades, not what happens over 6 months or a year or 2 years. But it has implication, but it does have implications for, you know, so if we do care about those short runs, the short run structural imbalances that happen, then the question is, well, what kind of policies might we put in place that help people that are affected by technological changes, right? That are not able to adjust as quickly, that don't slow down the pace of that change, which ultimately leads to the higher real GDP growth. Right? Yeah. Similar arguments around free trade and have been about free trade. So just to make a really a kind of quick transition on that one, right? So people get hurt by free trade when you reduce tariffs. The North America Free Trade Agreement initially, now we have a different version of that now, but in NAFTA, the North America Free Trade Agreement, during Clinton administration, was a provision for anybody that lost jobs due to opening up, let's say, the border and reducing tariffs with Mexico, right? Would have access to funds to get retrained, to go to community college, or go to college and get retrained, for example. That was actually part of the NAFTA agreement. How many people actually did that? I don't know, but you know. Yeah.
One other question I have is, how is given the production function for the United States, how's the marginal rate of substitution between capital and labor changed over time?
Yeah. So I'm thinking through. I don't know the answer to that direct. I mean, in terms of like just knowing the data right offhand, but it's going to depend on the industry partly, but the type of jobs are going to change, but so one is always tempted to do the same thing I was just talking about and say, well, okay, so we see workers in McDonald's being replaced by ordering kiosks, for example, right? You said, well, they're substituting capital for labor, right? And you said, well, so that marginal rate of substitution must be increasing then, right? That would suggest that if firms are profit maximizing. But at the same time, we have other industries where there might be new software, but it's workers working with the technology, not replaced by the technology. In fact, that's sort of the general view, is that how do we work with the technology and enhance the productivity of workers, which would cause you to want to hire more workers, right? Which is kind of this story, actually, which is kind of the theory here that we're talking about. So I don't know the answer to that directly, actually.
So since the early 1900s, the United States has largely shifted from a manufacturing economy to a service economy, correct?
More so, yeah.
I was going to say, if we speak broadly, obviously very broadly, what would be more capital intensive, the service industry or manufacturing?
Generally,
I'm assuming
services.
generally manufacturing. Oh, services.
Oh,
Okay.
labor intensive?
No, I said capital intensive.
Oh, capital intensive.
Yeah.
Yeah, probably. Although we can automate banking services, for example, right? They're much more automated. We don't need as many people to do that, right? Because we can go to the money machine, or we can just put money in our account online or on our phones, right? Or have it taken out, right? Just with payments on our phone, Venmo, for example, or whatever. Right? So, and there are other services like that. So one could think about, in the future, one could think about ride sharing, for example, which right now is a combination of labor and capital, right? Uber, Lyft, etc. But with a move to autonomous vehicles in the future, that will largely be much more capital intensive, that service, right? And much less labor intensive. We absolutely will have driverless, right, vehicles on the roads in the next 20 years and whatnot. Yeah, which will be great for senior citizens, for example.
Well, yeah, my main question just came around the thought of when looking at the Cobb-Douglas function with the 0.3 and the 0.7. I was curious if that changed from when you taught the class 10 years ago or 20 years ago, or if that's numbers that were used.
Yeah. I don't know the empirical answer to that one. So just a really quick aside on that, and then we'll wrap things up. Let me go back and share. Sorry. So we'll come back to this in chapter 6, but right, if we have y equals a times k to the 0.3 and to the 0.7, where do these things come from? If we take the natural logs of both sides, right, we can talk about this is the ln of a plus ln of k to the 0.3 plus ln of n to the 0.7, which we can then say is the ln of a plus 0.3, the ln of k plus 0.7. So ln of, so this is ln of that, right? 0.7 ln of n, right? So this is like, so if you're taking econometrics, this is like this is a regression equation, right? This is alpha plus beta times x1 plus beta 1 times beta 2 times x2. These are estimates, parameters, right? We estimate those, put hats over that, let's say, right? So we have data for Y, we have data for capital. I mean, we actually have data. We have data for employment, right? So we can run this regression with these variables, right? In the regression, this is the constant in that regression. What is that constant? That is the log of A. All right. So the question becomes, in these regression equations, have those changed? Because those are those parameter estimates right there in the Cobb-Douglas. That's what they are. And I don't know the answer to that.
I'm sure I could probably ask Dr. Romero. He would probably.
Yeah, he might. I don't know how much they've changed. Yeah, overall, remember, this is a whole economy, so there's these changes that happen within industries, but then it's not clear. Yeah,
That makes sense.
so,
and then one last question I had.
and it doesn't. So just to be clear, it doesn't change anything conceptually about the model or the graphs that we had. I mean, it does in terms of the actual slope, but as long as they're less than 1, there's a diminishing returns to either capital or labor, either one. And so ultimately, it doesn't change the conclusion that, ultimately, to continue to have a growing real GDP, A has to increase.
Okay.
Yeah. So I mean, so a different question, another version of that question is, can living standards increase forever? Can real GDP keep growing forever? And the answer is, well, yeah, if A is increasing. Not if A is not increasing, not necessarily, because there are diminishing returns to capital and labor, according to that production function, right? As long as those exponents are less than 1. So whether one is 0.3 and 0.7, another one is 0.8 and 0.2, or 0.25 and doesn't matter in some sense. I mean, if they add up to, ultimately, whether they add up to 1 is what matters. That's why the Cobb-Douglas function is just it's nice, and we'll be able to see that later on. It allows us to do some simplifications, because ultimately when we get to chapter 6, we can talk about GDP per capita depends on capital per worker, and it depends on A, right? And capital per worker, there are diminishing returns to that. So the only thing in the end, in terms of output per person, which is really what living standard is about, is A. It doesn't. Our story is the same as we're telling in chapter 3. I just have more to say about it. Doesn't the actual value? Those actual numbers don't. Those actual exponents don't matter in terms of, as long as they're equal. But if they're equal to 1, then we can do some nice math.
Okay.
Yeah. Yeah. It just simplifies the math. Yeah.
My other question was, given the long-term model for the labor market, why is the assumption made that the substitution effect will dominate, given that the textbook states that empirical evidence suggests over the long term the income effect is stronger?
It's mixed. It's mixed. It's mixed. So we can. So that has to do with the slope of the labor supply curve. So if the income effect is bigger, it means it's a backward bending labor supply curve, right? So people have done work on this in microeconomics and talked about at higher wage levels, right? So you can imagine this, that if the wage rate was, conceptually, if the wage rate was really high, right, you would supply less labor. Like if you got $1 million an hour, like you'd supply 1 hour of labor, or 30 minutes or 10 minutes or something, right? So a really low level, which means that at low wage rates, maybe you would, as wage rates go up, you supply more labor. And at some point, maybe it becomes backward bending, right? Which means that the income effect is outweighing the substitution effect. That's what that means. And so the argument is that generally we're operating in the upward sloping part of the labor supply curve. Doesn't mean it can't be, doesn't mean conceptually it can't be, but that's the range that we're operating in. Even if that was not the case, right? Even so, that has to do with the slope, right? As I said, is it upward sloping? Is it backward bending, right? So the in-between cases, what if labor supply was vertical, right? It just, the wage rate didn't matter, right? The substitution income effects basically just offset each other, right? It doesn't, it would, we just don't see that. Increases in, I mean, what that would suggest is increases in labor demand have no impact on employment. Now, and that's not what we see. When there's an increase in technology, for example, which increases the labor demand curve conceptually in our model, right? So what we would expect then is to see less labor employed. If the income effect dominated, right, be less labor supplied as the real wage rate went up because of a shift of the labor demand curve, right? And so we'd see less employment. Now, the less employment would be offset by the fact that the less employment is more productive, so the production function has shifted up. So we could have higher real GDP. We could still have higher real GDP, but we just don't generally see that. We see when there's increase in technology, when there's increase in capital per worker, we see increases in employment along with increases in real GDP, which suggests that labor supply curve is upward sloping, or the part that we're interested in and generally operating in is upward sloping.
Okay, thank you.
Yeah. So I will say that the work in that area is empirically is a bit fraught, but yes, it does have important implications. But then we have to think about what we see generally macroeconomically, and yeah, kind of like it's kind of like we can talk about later in the course too about impacts of changes in the minimum wage, like the empirical evidence on that is varied. It's mixed. And so it has to do with the data that people are using and the assumptions underneath that. You can get different results. And I mean that matters. I'm not saying they're playing, it's not the matter they're playing with the data. I'm just saying it's not clear, and the particular environment matters for that, for example. So, yep.
Thank you.
All right. So see you next week. Okay. All right.